I do hard things all the time. Breathing, everybody can breathe. I just have to focus on it a little bit more. So if there's just like a long pause, don't worry, I'm fine. If I sit down for a little bit, don't worry, I'm fine. If I fall to the ground and start to turn blue, please worry. That's a good sign. That's a sign that things are not going so well. Okay, I forgot what the conditions were. Is that really blue?
Is that not blue?
He's white. It's hard to tell. All right, so let's talk about the reality of where we are. We're going to spend 2 more days working with integration, and then we're just going to do a hard stop. We're going to put the brakes on. There's going to be no more integration techniques. I also need to let you know that the stuff we've been doing for the last week is not on your semester exam.
Thank you.
The semester exam covers just the first 5 units. So to help you get ready, here's what you've got. All those beautiful like PowerPoint vocab slides that I created over there, I shrunk them down for you. So here's my thought. I think the really smart kids are going to spend some time cutting these out and turning them into like flashcards. You've got 10 pages worth of important ideas and vocabulary and all sorts of things like that. So that's like 60 different flashcards that you might want to create. Now here's the thing though. If all that you do is turn these into flashcards but don't use them, don't actually like engage each other in conversation about these things, don't like do something significant, it is a waste of your time. I don't think turning them into flashcards is like the one and only thing. Other folks might want to just keep this as like one packet and go through and read through it and highlight it. You do what you want. But I wanted to give you this a thing that I think would be really helpful as a good summary of everything that we've done so far. Everybody okay? Now, let's say you turn these into flashcards, and man, you have memorized every single thing that shows up on here. That won't be enough. Because our test isn't going to be a test where I'm like, hey, what's the difference quotient? Hey, what's the existence of a limit? Our test is going to be you're doing stuff, right? You're solving problems. You know, you've been in a math class before. So what I also pulled together, that's this packet over here that I want to take a look at. This is the thing that like looks like it's a test.
That's right. That's not a test.
Okay, it's not a test.
Before a test.
Yeah. There are a grand total of 47 multiple choice questions. Your semester exam has 33 multiple choice questions that you will solve in 90 minutes. These 47 multiple choice questions cover everything. Everything that we have studied this year, all the important concepts that you need to know are represented here. Starting tomorrow night, your homework is going to be to do like 12 to 15 of these, and I'll tell you which ones you're going to do every single night. And it's going to be a mix of units 1 through 5. Now what I'm not going to do is say, hey guys, tonight everything's going to involve derivatives, because that's not how it's going to be on the semester exam. I'm going to pick 12 to 15 questions. They're going to cover all the units, all the ideas, and you're going to like go through and do as best you can. In class, Wednesday, Thursday, and Friday, if you get, I'm looking on page like 18. So pages 18 through 24, there are 7 open-ended free response questions. I don't think you've seen any of these before. These are all brand new. These are questions that I've either written or they've come from the College Board. And this is going to help you get ready for the free response. So right now what you have in your hands, Aaron and other friends, between those PowerPoint slides and these problems, this is it. This is all that you are going to get from me. This is all that you need to do in order to study. Questions? Aaron, do you have a question? Okay. David, you're good? Okay, other reminders, Wednesday after school I'm going to stay for tutorials till about 2:30, maybe a little bit later, it just depends on some other stuff that's happening. And then Friday we have a study jam from 4 until 6 for Calculus AB students and Calculus BC students, where we're going to work through other calculus questions that are not on here that you haven't seen before.
And we'll be meeting in here.
And we're going to meet in here. Next Monday, you all are going to take the semester exam in the cafeteria, along with the Calculus AB students and the AQR students. That way they're like, I'm there and I'm going to manage all the different things and all will do it.
So we're, all 3 classes are sitting on the cafeteria.
Yeah. I mean, in total, that's only like 70 some odd students.
Oh, okay.
That's the
It's not bad. It's not bad.
That's not bad.
It's not bad at all. All right. That's good. All right. If you guys could take out your homework, we're going to check the homework right before you start the next sticker challenge.
No stick.
And if somebody could turn that off, that'd be great. All right. Today's sticker challenge is all integration. It's all definite integrals. So you guys know the process. Whenever you're going to evaluate a definite integral, you find the antiderivative first. We stop writing the dx. You put in that evaluation bar from -2 to 1. You evaluate the antiderivative at the top limit. You evaluate the antiderivative at the bottom limit. You subtract them from one another. So your antiderivative, 1/3 x cubed minus 3x squared plus 12x. Evaluate from -2 to 1 and simplify. You should get 48. Is everybody okay? Yeah. All right, number 2. Now this one's a little bit mean because in order to find the antiderivative, you're going to have to do some stuff with algebra. So I'd rewrite this as 2x times x to the half, which becomes 2x to the 3/2. Antiderivative, add 1 to the power, divide by the new power. So your antiderivative 4/5 x to the 5/2, evaluate between 4 and 9, and you're going to get 44 over 5. Number 3, another tricky one, 1 over x square roots of x. I'd rewrite the denominator as x times x to the half, which is x to the 3/2. Because it's in the denominator, rewrite as x to the -3/2. I'm curious, how many of you guys were able to rewrite the integrand correctly as x to the -3/2? And it just like felt like this was the right thing to do?
Yeah.
Add 1 to the power, divide by the new power, you get -2x to the -1/2, or -2 over the square root of x, evaluate from 1 to 4, final answer is 1. Number 4, antiderivative cosine 4 theta, 1/4 sine of 4 theta, evaluate between -pi over 4 and pi over 4, final answer 0. Maybe that was a surprise for some friends that it came out to be 0. Carmen's like, no. No, I knew it was 0. It's the kind of girl I am. Alright, number 5, antiderivative of 2x minus secant of x tangent of x, antiderivative of 2x, x squared, antiderivative secant x tangent of x, secant of x. Evaluate from 0 to pi over 3, plug in, subtract, pi squared over 9 minus 1. Was everybody okay with the antiderivative? Okay, good. And honestly, if it's the free response, you can stop here. If you don't know what secant of pi over 3 is, don't roll the dice. Don't be like, let's see if I'm going to figure it out today. Don't. But when it comes to the multiple choice, you have to simplify. You have to simplify. Alright, number 6, e to the x plus e to the -x, the whole thing squared. I would multiply this out first. Becomes e to the 2x plus 2e to the 0 plus e to the -2x. Find the antiderivative, 1/2 e to the 2x plus 2x minus 1/2 e to the -2x. Plug in the 3, plug in the 0, subtract. 1/2 e to the 6th plus 6 minus 1/2 e to the -6. Number 7, hopefully an easy one, antiderivative of 5e to the x is 5e to the x. Evaluate natural log of 2, evaluated 0, subtract, a little fancy canceling over here, you're going to get 5. Number 8, last one, I'd probably break this up as 2 separate fractions. Or, Lewis, your favorite, let me bring that t cubed up into the numerator and make it t to the -3rd and distribute. Fine by me. Either way, you're going to get natural log of absolute value of t minus 2/3 t to the negative 3/2. Plug in. Honestly, if you stopped here, it's just fine. If you want to show off, natural log of 4 plus 7 over 12. I'll just leave that up there. Hi there. Bring it in, I'll sign it. Give it a pen. Thank you.
I can't read it.
You like it? Okay. So I'm curious, how are all the friends doing with integration? For the most part, we're okay? Alright, it's time for quiz. You can put the homework in the middle of the table. We're going to do a little sticker challenge. Polymon, let me make sure I explain. There's 4 problems here. You're going to do all 4 of them today during this next block of time. Don't confuse him. Please don't confuse him anymore. 2 minutes. 3 and 4. Alright, and for the friends watching at home, you might just want to fast forward about 10 minutes into the video. Alright, enjoy the ride. Okay, 8 minutes. Six minutes left. everybody who's missing either sticker number 1 or sticker number 2. If you get all the antiderivatives right, even if you evaluate incorrectly. If all your antiderivatives are 100% right, you earn those missing stickers. Bless you. Alrighty, friends. Alright, good news. You don't need to simplify all the way in order to earn the sticker. Andrew's like, why didn't you tell me that in the beginning?
Myra's like, I hear Myra.
Remember, if he falls to the ground and turns blue, then maybe I don't need to worry about this anymore. Alright, so number 1, you're going to rewrite the integrand as x times x to the half, which is x to the 3 halves. Antiderivative is 2/5 x to the 5 halves. 2/5 x to the 5 halves. Evaluate from 9 to 1, so 2/5 times 9 to the 5 halves minus 2/5 times 1 to the 5 halves. I would say getting to there is good enough. Okay. Number 2, antiderivative 3e to the negative x is negative 3e to the negative x, plus antiderivative of e to the 3x is 1/3 e to the 3x. Evaluate from negative 1 to 0, plug in the 0, negative 3e to the 0, plus 1/3 e to the 0, minus all that stuff over there. If you stopped here, okay, we'll count that as good. However, I just want to give you a second to kind of look at the rest of the work that I did and how I simplified. That thing that I boxed is what I would expect out of you on the multiple choice. I'm not going to give you any, I'm not going to give you this as an answer choice or this as an answer choice. You can stop here on free response, but you gotta go all the way to the box answer for multiple choice. How many guys are at 2 out of 2? Nice. Alright, number 3. I bet you guys know exactly what to do. Rewrite this as 2 separate fractions. 1 over y squared over y. The integrand becomes 1 over y plus y. Antiderivative, natural log of the absolute value of y. You have to have the absolute value bars for that to be considered correct. Plus 1/2 y squared. Evaluate from 1 to 2. You're going to get natural log of 2 plus 2 minus natural log of 1 plus 1/2. Now, sadly, natural log of 2 plus 2 is not natural log of 4. I mean, I'm just saying, in case somebody had natural log of 2 plus 2 as natural log of 4, David. I mean, that would be like wrong.
Oh no, I didn't do that.
Oh, okay, not you. No, not you. Okay, now, some people had natural log of 2 minus the natural log of 1 plus 3/2. And natural log of 2 minus the natural log of 1 plus 3/2. It's not wrong, it's just a little odd. Because the natural log of 1 is 0. So we wouldn't write natural log of 1, you would just write 0, right, Carmen?
Yep.
Just checking. Alright. Alright, and the antiderivative of 2 theta plus sine pi theta. Theta squared minus 1 over pi cosine pi theta. You evaluate from negative 1/2 to 1/2. You're going to plug in. If you get here and you ran out of time and you didn't get anywhere further, we're going to call that good. The most correct answer, though, is 0. So, just so that we're on the same page, in order to earn sticker number 3, you need to have gotten 3 of the 4 right. Any 3 of these 4 perfectly correct gets you the sticker.
Oh, nice.
I tried. If, wait for it, if you found the antiderivative correctly, the 2/5 x to the 5/2, the negative 3 e to the negative x, 1/3 e to the 3x, the natural log absolute value of y, plus 1/2 y squared, the theta squared minus 1 over pi cosine pi theta. If you got all 4 of those right, even if you made a mistake on the simplification, go get yourself sticker 1 or sticker 2 if you're missing it. Okay? Go get your stickers.
Yes. This is just skill.
This is sticker number 3.
You have David's sticker. Take your place.
Oh yeah, I earned you those stickers.
Oh, nice. Everyone's up. Everyone's earning stickers. I am a good teacher. Even if I can't breathe. Be careful.
Those are what we call stickers.
Oh my god.
Steven!
Steven!
Steven, breaking my stuff!
I got scared.
Also, I
I've had that thing with me for a long time.
Are those nails?
They are nails. No, not you. I have others in line first.
It's the thing you give at Walmart. I mean, I know you did it at Walmart, but it's the same concept.
Yeah, I didn't get it at Walmart. But I have seen them at Walmart for far less than what I paid for it.
Yeah, because it's metal and high quality. The other ones are plastic.
My hand looks small. It is small.
And I would avoid putting it on your face. Other people have put it on their face and then like stuck their tongue out. So yeah.
Wait, what?
And doesn't want to. It's gonna
Wait,
wash
what?
hands.
Wait, what?
Some people have like put their face on it and then stuck their tongue out.
Why?
No, but
Put your face in. Just put your face in.
What happens?
Don't stick your
Well,
tongue.
no, it just means that like they licked it and other people have touched it. All right, let's go.
here's my nose.
Oh my, is it a full sticker chart?
Yeah.
Oh. All right, excellent. So congratulations to all 11 of you.
Congratulations.
You just earned a 100 on the final quiz of the third 6 weeks. Woo! That's all done. Okay. There are no major assessment grades left. The only grades left are going to be like homework assignment grades. Aaron, we need good homework assignment grades this week. All right. So here's the goal for the rest of the period. The rest of the period, the goal is for us to complete, if we're lucky, 3 of these 4 questions. I'm on page 17 in the student packet. Okay. All 4 of these questions are going to involve integrals of some sort, in some way. but likely you may not recognize it when you see it. I want to go over the first one together and then give you guys some time to practice and play around with the remaining three. These are rough, okay? But I want to remind you, this is not on the semester exam. For the BC students, Unit 6 is not on there. All right, Myra, can you give it a read? The first
A
one?
water balloon is launched from the roof of a building at time t equals 0 with a vertical velocity given by the expression v of t equals negative 32t plus 40 feet per second at time t seconds. At t equals 2 seconds, the height of the balloon is 100 feet. Determine the height of the building.
Okay, I want you to have a 1-minute conversation with somebody near you. You see this question on an exam. What's your strategy? What are you going to do?
No. You did. You have to find Wait, but would you find?
That's what I was confused.
You would find. So you can find. But it's, so it gives you a good team position. So you. So what you end up doing 100 minus whatever. Yeah.
Because the function.
I'm amazed. Nobody is like drawing a picture of this at all. It's in your brain. Okay, plenty of room up there. All right. So, I mean, big brain, not empty brain. Big brain. All right. Water balloon launches the roof building at time t equals 0. All right. So you've got the velocity. And I'm launching a balloon from the top of a building, and the balloon, assuming that we're doing it here on Earth where we have this thing called gravity, is going to go up, and it's going to come back down. Is everybody okay with that?
Yes.
All right, so we've got the velocity, and we know that at time t equals 2, the height of the balloon is 100 feet. How are we going to use our integration skills to solve this problem? Stephen, what are your thoughts?
The antiderivative of v of t, and then when you solve for,
Why are you going to take the antiderivative of v of t?
because that will solve for displacement.
Well, let's be careful about this. Okay, we've got velocity. If I were to take the derivative, we'd go from velocity down to,
Displacement.
not displacement, acceleration. What I need is height. So I want to go in this direction. If I take the antiderivative of velocity, we're going to get height, or depending on how you want to describe it, you could say you're going to get displacement, right? It's going to give you a change in position. Yes, Stephen?
I said antiderivative.
You did say antiderivative.
Yes.
Okay, my bad. My bad. All right. Everybody okay? So here's the thing. If what you want is height, you could say, let me take the antiderivative of negative 32t plus 40 dt, and that should be pretty easy. Antiderivative? Antiderivative negative 32t, negative 16t squared plus 40, not x, 40t, be careful, plus Charlie. I don't know what this is, but this is going to be the expression that gives me the height at any particular time. They told me that at time t equals 2, the height's going to be 100. So what am I going to do? I know that h of 2 then is negative 16 times 2 squared, 40 times 2 plus c, and when I plug in 2, I'm supposed to get 100? So I can simplify, negative 64 plus 80 plus c is 100. What is that, 16?
Yes.
So I think that means that c is
84.
84. So my height expression, h of t, is negative 16t squared plus 40t plus 84, and you want to be careful, because a lot of folks are going to stop there, and we're not done. Why are we not done? You're frozen for the back. Why don't you stop here? Always go back and read the question. David, why are we not going to stop here?
For the height of the building.
You want the height of the building. Aaron, how are we going to find the height of the building?
Don't you just take what you have for the balloon and you have to add 100 to it because it's at the height of the building?
So you're saying we're going to add 100 because that's the height of the building?
No, the balloon is launched from the roof of the building, so you have to add 100.
The balloon is launched from the height of the building. When is the balloon going to have a height equal to that of the building?
8 equals 0.
At time 0 in the very beginning. Right, so like right here when you're just holding the balloon is time 0. So if what I want to do is I want to get the height of the building, I could just say find h of 0, and I think we're going to get 84 feet. Is everybody mostly okay? This is option number 1 for solving the problem, Lewis. Yep. Okay, make sure you sign out and grab the pass. This is option number 1 for solving this problem. There's a second option that I want us to talk about. Everybody's good with option 2? Option 2 involves using your fundamental theorem of calculus. So option 2, we're not actually going to complete option 2, but option 2 says use the fundamental theorem of calculus. Why? Lewis, I think you're signing up for a college visit. Okay. Why? Here's what I really care about. Why would I even think about fundamental theorem of calculus here? Why would I want the 10 of you to think about fundamental theorem of calculus here? Don't talk to me, talk to your neighbors. Why could we use fundamental theorem of calculus here?
You take the final unit minus the initial unit.
So displacement.
All right, the conversations that I just overheard in all 3 groups had something to do with velocity is telling you how the height's changing. In order to use the fundamental theorem of calculus, FTC says the value of the function at the end equals the value of the function at the beginning plus the total change. So you always need to have 2 of the 3 pieces. Do we know the final value? Right, that's the height of the balloon at time t equals 2. Do we know the initial value?
Not yet.
No, but that's what you're after.
Yeah.
Do you know the rate that that function is changing? That's what the velocity is. So my setup here would be something like h of 2 is h of 0 plus the integral from 0 to 2 b of t dt. So in this case, you would find the antiderivative and evaluate that antiderivative. And you're going to have 100 equals thing that you don't know plus whatever you get. Everybody okay? You're going to get the exact same answer. Do it either way that makes sense to you. It's all good. Andrew, you okay? All right. I want you guys to see what you can do the second one. Trust your instincts. I bet you guys know exactly what to do here. Andrew, what thoughts do you have? I'm not looking for a final answer, just what are your thoughts?
Find the antiderivative of f double prime.
And why would you think to find the antiderivative of f double prime? Why would that be helpful?
Then we can later then find the antiderivative of f prime to find the function of f of x.
So if you're at f double prime and you find an antiderivative, what are you going to get?
F prime.
You're going to get f prime. And then your strategy after that?
Oh, then plug in 0
Yep.
into the f prime
Yep.
to find c.
Yep.
And then after that, find the derivative of f prime.
Antiderivative?
Yeah.
Is everyone thinking like something along these lines? Start with f double prime, find an antiderivative, get to f prime. Now here's the thing. Your notation, we're gonna be a little flexible here. I bet most of you guys could go straight from f double prime to f prime without writing the antiderivative symbol. Right? Antiderivative of e to the 4x
1/4
should be 1/4 e to the 4x minus 1/4 e to the negative 4x. Uh-oh.
plus c.
Plus c. Plus c. You have to get that part in there. Now, how am I going to go about finding c? That's why they gave me this guy here, which I love to call the initial condition. This is the one place that I know the value of the derivative. So f prime of 0 is 1/4 e to the 0 minus 1/4 e to the 0 plus c is supposed to equal 4.
C equals 4.
So that's a fourth. That's a fourth. C is going to be 4. So f prime of x is 1/4 e to the 4x minus 1/4 e to the negative 4x plus 4. Great, we get f prime. Aaron, everything okay? Now I need to get to f. Yeah.
1/16.
Okay, antiderivative of 1/4 e to the 4x is 1/16 e to the 4x.
Minus 1/16.
Minus 1/16?
Yes, e to the negative 4. Wait, I mean positive.
Right, it's going to have to be positive because this is already a negative 1/4 that you're going to be multiplying by. Plus
4.
4 or 4x?
4.
4x. Be careful.
Plus c.
And here's where I want to be really careful. Don't use c again.
Plus Z.
Plus Z.
Right? What you need is a constant of integration. Is everybody okay with this idea? What's the problem with writing plus c, Carmen? Why don't we want to write plus c?
Because then you're saying that C is equal to the same C.
If I use c over here, I'm going to think it's this c from over here, and this is what a mathematician would think. So one option is call it something else, call it d. Another option is, you know what, like when I integrate, I'm going to call this c sub 1. So c sub 1 is equal to 4, and now I'm going to call this c sub 2. It doesn't matter which way you want to go, but don't use the same variable again. And so then from here, probably no big deal. F of 0, 1/16 e to the 0 plus 1/16 e to the 0 plus 0 plus c sub 2 is 4. C sub 2 is not going to be 4. Because this is 1/16. You're adding another 1/16, so now you've got 1/8 or 2/16 plus C2 is equal to 4. If you subtract, I think you're going to get 31/8, which means that your final answer is 1/16 e to the 4x, 1/16 e to the negative 4x, plus 4x, plus 31/8.
So we have to do all that on free response.
On free response, you have to. Okay.
You can't just leave it at c squared.
Well, and it's not c squared. C squared would be an exponent. This is just like c sub 2.
Or like, yeah, the other thing.
Right, well, it depends on what the question is. What are they asking for? They want the function f of x, so your answer has to be the function. So make sure you give me the function. I think everybody's doing mostly okay? right, let's find a new partner.
Come here, David.
Okay, and with your new partner, really choose wisely here.
Oh, yeah.
Problem number 3. I have never had a partner group really be successful setting this next one up.
Oh, exactly.
So let's see how smart the particles are today. Problem number 3, you've got 2 minutes to work with your partner and come up with a plan.
Or the exact.
It's next to me.
Okay, area 3. Oh, okay. Perfect.
So thoughts on that so far?
This is definitely.
Trying to figure out what it's like negative 36 is like in the equation.
Okay. So I'm asking you about area, right? How would you ever find area? If it was a rectangle that we're talking about.
This is grammar load.
It's
If it's a circle, that means
Reverse thing.
It's not, yeah, it's not like,
This
you
is
don't have the vertical.
We're going to talk about that.
So you gotta find the area.
because look, unless
Yeah. Oh, snap. But is
Okay.
Wait a minute.
Because C is so it's the constant in the situation.
It means X times
Wouldn't
B.
have to be 0 to.
All right, friends. I wanna pull this together. We only got 7 minutes left, and if we don't do anything else, I want to make sure we do well with this one. So, interesting experience. Lewis and Giselle have made some good progress, at least with their setup. Nice job. Other folks have drawn an x-axis and a y-axis with a question mark next to it. Lots of different things going on here. Okay. Find the exact positive value of C if the area between the graph of y equals x squared minus c squared and the x-axis is negative 36. I heard a lot of conversations about what is this the graph of. What is this the graph of?
Circle.
Not a circle.
Parabola.
Not an ellipse. It's a parabola.
Oh.
Aaron, why is it a parabola?
Because high the is 2.
You've got y equals x squared. You've got a quadratic. Minus c squared, where c is just some constant.
Oh.
So imagine x squared minus 3 squared, x squared minus 5 squared. What is that the graph of? Has to be a parabola. Now take that basic parabola that you know of, the one that passes through the origin. How is this one different?
Move it to the left.
Move to the left.
Oh, no, it's to the right.
Shift to the right.
No, you're right. I think you're
Sit down.
Shift it down. Right? This is just
X.
regular parabola y equals x squared. Minus some stuff shifts it down. If you wanted to shift left or right, you would need parentheses. So what I know is that the graph of the parabola looks something like this. And the area is supposed to be not 36, negative 36. Have another strategy conversation. What are you going to do? Now that you've got the graph in front of you, what would you do from here? I think it's still a tricky question.
It's not a simple
You really be able to specify, because you can't set its own boundaries.
So knowing that this has to be some sort of an integral question, the way that we find area, you need to know four things. You need to know the function, we've got that. The x-axis, we've got that. And the other two things? The limits of integration. Where are the limits of integration going to be, Lewis?
Negative A to A.
From negative a to a. Okay. Are those the roots? Right, you're going to do your integration from the first root to the second root. Now, I'm not so sure that I'm a big fan of negative a to a. If these are your roots, what makes them so special is that x squared minus c squared has to be equal to 0. So where are the roots? I could make this x squared equals c squared. So x would be c. Positive c and negative c, and I've got to consider both. So this would be the point, negative c comma 0. Stephen, you okay there? And c comma 0.
He's having a math moment.
Oh, you're having a math moment. Do you need to be alone? So we get the antiderivative. Yeah, think about that. That was a good one. The antiderivative of x squared minus c squared from negative c to c, that has to be equal to negative 36. Now I would hope that once we're here, finishing it off not too bad. We're going to find the antiderivative. Antiderivative is 1/3 x cubed minus c squared times x. Evaluate from negative c to c, and that's supposed to be equal to negative 36. Plug in the c. I've got 1/3 of c cubed minus c squared times c minus 1/3 of negative c cubed minus c squared times negative c equals negative 36. There's no more calculus happening at this point. This is all just algebra stuff. So I've got 1/3 c cubed minus c cubed minus over here negative c times 1/3 is a negative 1/3 c cubed. Negative c squared times negative c is a positive c cubed. We can simplify a little bit. 1/3 c cubed minus c cubed, I think, is negative 2/3 of c cubed. Minus over here, 2/3 c cubed equals negative 36. Maybe you want to use your fraction killer skills, multiply by 3. Negative 2c cubed, negative 2c cubed, negative 108. Negative 4c cubed equals negative 108. So c cubed is 27. And c is going to be 3. Okay. I know there's a lot going on. And I also know down here I was going really fast, but honestly, once we found the antiderivative and we plugged in, this was just algebra that I would expect everybody to be okay with. Alright, tonight's homework, if I didn't say it yet, it's assignment number 92 in the problem set packet. This is the last thing from the problem set packet. After tomorrow, the problem set packet can stay home, and it's all the review materials that need to come every day. See you later. Are you okay with the first two, David?
Yeah.
He won't be back until.
What?